Hello, students. I'm going to start my lecture week 4. This is about properties of materials. So this is unit 2 in our textbook. We are looking at the properties of materials. Today I prepared two modules. So one is the properties of material. This one, that is the last chapter of unit 2, and then next module will be the material manufacturing process. That is just introductory. So this lecture may take 45 minutes, less than 45 minutes. All right, so this is unit overview. So we are here. So we are learning about the manufacturing material. So we looked at material and manufacturing, how they are related, and then last week we looked at structure by looking at their bonding method, like ionic and metallic or covalent bonding, and then how these bonding methods affect on the material process, material properties, as well as we looked at the periodic tables of atom, and so the periodic table illustrate the characteristics of atom by exposing the different shapes, different number, and the different formation of electrons around the atom that also influence the structure of materials. And this week, this module is looking at the properties of materials, what kind of properties of material have, and then that is a indicator of choosing material in manufacturing. So these are learning objectives. Select material based on understanding of various properties. So we haven't used the specific term for properties. So we will define and then use the term related to material properties this week. And your goal is to identify 7 major types of material properties. This is the highlight of today's lecture. The 7 types of material properties, and describe how mechanical properties can affect the way material react to applied force. And this one also is important, stress strain diagram. The diagram, I will explain this one, but this explain why and how materials react to certain force. And the last one is describe how chemical properties affect the way material react to other atomic elements. The chemical elements of the material uh, will be related to corrosion. So I'm gonna explain why the metals are corroded, or why aluminum or other metals are not corroded. So these are keyword. We are looking at this keyword in the lecture. All right, so this is definition. So material property is traits or quality that are specific to a material that we define properties. And we're gonna look at what kind of properties material have. So these are a diagram, the big picture of this lecture. So last week we looked at this internal structure. So that was last week. So we looked at types of atom and bonding types, ionic, covalent, metallic. These also influence the structure of materials, and also molecule structure, grain, crystal, polymeric. So the grain, I haven't explained this grain because we haven't looked at the wood surface. So if you look at the wood, let's say this is wood lumber. Wood has certain like a pattern, right? This represent aging line. That is we call the grain. So that also grain pattern also affect the properties of the wood. And then crystal mean certain pattern types of structure. So let's just say this is a material and that has certain structure, pattern structure. that is crystalline structure. And polymeric is we can see this polymeric structure in the plastic, such as like carbon and hydrogen bonding, hydrogen. So, and then this is like make a chain, like chain type material, like this. These types of chain type material structure we called polymeric. One structure is monomer, but multiple monomer is polymeric. That is plastic. Right? All plastic has this similar structure. All plastic like this. This is plastic. This has also polymeric structure. And this week we're looking at the property in here. So we will look at 7 properties. So physical, mechanical, chemical, thermal, electronical, magnetic, and acoustical and optical. So, and then condition is also influence the material selection. So chemical condition and radiation and mechanical load and thermal, electromagnetic field, sonic force. So, but we are focus on here in this class. All right, so types of material properties. So I will present 7 properties, 7. So physical, mechanical, chemical, thermal, electronical, magnetic, acoustical, optical. So maybe you need to memorize the 7 properties. So I'm gonna explain the memory technique. So I have 6 years old girl, so she's learning word. So I told her like computer, but she understood like she's not good at the word. So she said com pu. She doesn't know the letter U, so she forgot letter U. T E-R. So I said computer, but she said she understood computing. So that is her understanding of computer. So actually computing. So this is 7 properties. You can memorize like this, computing, because it was computer, but forgot U, and then mistakenly put the A instead of R. So computing. So C, chemical, O, optical, M, mechanical, P, physical, T, thermal, E, electronical, A, acoustical, right? So let's memorize like this way: computer. All right. All right. Let's look at the first one: physical property. So physical property we can see by a macrostructure. We can see this macrostructure. This macrostructure. So physical properties means characteristics that describe by size, density, or surface texture of the product. So the first one is like density. So density is a indicator of an indicator of selecting material. So often the density means we in the science or mathematics we illustrate density as mass over volume. That is density, right? The measure of weight and certain volume material. So in US, we use the unit like pound over inch and gram per liter, right? That is the density. But the density determines the buoyancy on the water, because if density is greater than water. Water is 1. That means sink on water, but the density is smaller than water, will float. Because the, let's see here, the mass, let's say volume is the same with water, but the object mass is heavier than water, that means sink, and then lighter than water, that float. So that is also related to buoyancy. And in airplane body, so I prepared this example. It's an example question. Which of materials is most widely used in the airplane, in the current modern airplane? This is a example. And which material do you want to use for airplane? Or which material engineers want to use to build an airplane? Right? Let's look at it here. So airplane, first and foremost important criteria for airplane should be lighter, right? Lightweight. So lighter than other material. So cast iron is 6,800 and 7,800, very heavier, right? Heavy material. And aluminum 2,700, and copper 8,900, and gold 19,000, almost 20,000. Very heavy, right? Gold is very heavy material. So which material you want to use for airplane? Which one is more efficient in terms of weight, like aluminum, right? So that's why the aluminum is most widely used in the airplane. So this is true. So just aluminum is not enough strong, so that's why the engineers mix aluminum with other materials such as nickel or some iron or some of other plastic material. So they use the aluminum with other material, but primarily aluminum is the primary material for airplane. And moisture content is also critical, particularly for wood product. So moisture content can be illustrated by this formula. So oven dry weight, mean fully dried weight, and then weight of water. That is the expression. So let's say we have a wood, oven weight, dry weight wood that was 100 gram, but after 10 days, let's say it's 10 days, and then the wood observed some waste and then become 120 because wood sometimes like suck some water. So, and then what's the percentage of dry weight of material for this case? So use this formula. Oven dry weight was 100, and then weight of water. So that means that material became 120 from 100. So 20. So because and that is 20% of percentage of dry weight material. So percentage of moisture content. So these are example. So moisture content of green lumber, main fresh sawed wood, was almost 225. A very heavy this moisture content. But Western red cedar, that's my favorite DIY wood for outdoor. That is almost 35%. And then framing lumber, that lumber for frame, like construction framing, such as 2x4, 2x6, have 15 to 19. And then lumber for furniture, 6 to 10. So it depends on its purpose. but wood, most of wood has certain portion of moisture. So that is also one consideration for selection, right? So if you want to make a furniture, you may want to um, lower moisture content. So why the furniture, interior furniture should be low moisture content? Have you thought about this? Yeah. What will be the requirement of furniture? They should last uh, should be less there should be less modification by like temperature or moisture, right? That means has high resistance to moisture. So that's why the lumber furniture needs a lower moisture content. And then porosity is also a physical property, the ability to material absorb air or water, such as this is spongy, this is porosity. And then surface texture, also a consideration in selecting materials. So that surface texture means a way of surface of material look or feel, such as like stone brick or wool fabric or concrete. All materials has different texture, right? So there are different texture illustration, rough, like very rough, like a bumpy, slick, like a sleepy, and scratchy, like this, and smooth and silky, soft, freaky, like this. So all are different. And also depending on the medium, so metal and stone, concrete, wood. I cannot say certain material have certain texture because in the material, each material could have different texture depending on its different types of mix different types of its elements. For example, concrete is a mix of cement, sand, and pebbles. So when you make a concrete, we pour sand and pebble with the cement, and then they solidify that become this cement because right, cement is more stronger than I'm sorry, concrete is more stronger than cement because that has sand and pebble that grab that stand which stand from forces. But when you make a concrete, if you add more pebble, that become more like rough surface. But we add more cement and then less sand and pebble, that become more like sleek or more soft. That's uh, the principle. And then next one is mechanical properties. So mechanical properties like maybe primary considerations of material selection. So that govern how material will react to a force or load, and depending on types of bonding and structural arrangement of atom and molecule, and the number of type and imperfections in the material. So first and second were discussed in the previous lecture, and the third one was also discussed. But what does it mean imperfection in the material? Does that help for mechanical property or does not help? What's the imperfections? Yeah, so imperfection has several meanings, such as let's say a material, right? It it has certain dent or certain damage that could be imperfection. But in terms of material element, imperfection means the molecule level. Imperfection means, let's say this is the same, that this is a uh, ion, but in the ion, we can add other element, other material such as carbon, or sometimes we can add sulfide. Oh, I'm gonna use different color. That combine with the ion. So if add more imperfectious elements that become more hard, that makes the material more hard. So that means that withstand from the our force. So imperfection sometimes help withstand from the force. It depends on, right? So there are four types of mechanical force, like strength, and elasticity, and plasticity, and hardness. I'm going to explain these four types of force. That is also illustrated here. So, all right. So strength. So strength is the ability of a material to resist an applied force. So applied force can have different types. So there are, for example, compression, shear, tension, and torsion. So I have a very nice web resource that shows the different types of force. All right, how can I use this? All right. Oh, I want to go back to. All right, I'm going to copy this link. All right. All right. Okay. This is a website, one of my favorite website that shows different force. So the first one is compression. So that shows how compression influence the material. So compression test will be push, squeeze the material, right? That's compression. This is first type of force, right? And then second is tension, is dragging, pull out the object, the stretch, that's a tension. And then shear is pushing a material that cause take apart, they break out the object. That is shear force. And then torsion is twisting, right? So these are four types of force we can find in material. All right, so yeah, you can just visit this website and then test out these strength types of strength force. So compression, tension, shear, and then torsion. So these are different types of strength. And there are other mechanical properties: elasticity, plasticity, and ductility. I want to also explain this characteristic with this website. I'm going to. All right, this website, you can click this website, and Right. So these characteristics, so elasticity is the ability of material to undergo compression or stretch without permanent deformation. That is elasticity. And plasticity is ability to flow into a new shape under pressure. These are the mechanical properties. And this website show how the different materials react to the force. So such as wood, let's do the compress, squeeze that withstand here, number 3, level 3, and level 4 start breaking. What about stretch? Number 1, 2, 3, yeah. That means wood has more strength for compression than stretch, right? What about plastic? Like plastic has stretch go to level 3 and level 4, 3 and 4, right? And squeeze 1, 2, see, little bit high strength for compression, right? That's the plastic. And aluminum, we can also test out most strength for stretch, and also high strength for compression. What about brick? So brick maybe have like high strength for compression, but low strength for stretch, right? Like cast iron. Oh no, yeah, cast iron also has a low strength for stretch. Still is the same, right? These are the material properties, specific properties of different material. All right. So, and next is the one of the important point of this lecture. So, stress strain diagram. So this is stress strain diagram. Diagram. So this show material strength and elasticity and plasticity and ductility and brittleness. So if you are a mechanical or material engineer, you may need to test out each material before you use the material for the certain purpose. So this is a machine that used to test the material, says tensile test machine. So in this machine, you put the a material here, and then this machine stretch, and then see how much the material withstand from the stretch force. So this is important. So that shows the material's strength, but every material has different property or different strength, but has similar pattern. So I'm going to show you this example. Let's show you. Yep, right here. Can you see? So this is my girl's favorite toy, slime. So this is identical. Let's say this is a material that I want to test, and then my two hands are tensile test machine. So I'm going to stretch this um, slime and let's see how it change. right? So I'm going to stretch like this, and it elongated, right? And I'm pushing force, continue. I'm going to this, and I'm push more force, doesn't move. Oh, oh, did you see? It's broken, right? This is the material. But this characteristic is shown in this stress strain diagram. Let's go back to here. So this diagram is very important. So, this diagram has x and y axis. Not here. X, I'm sorry, y and x. So the y means stress. Stress means force per unit area that result from the applied load, like stretching load. How much the material gets stressed, how much force that material have. And then strain is physical deformation, like physical change, physical elongation. That means strain. How much the material elongated, that is strain, right? So when I just stretch the object, the material, that change the shapes with the force, that is this area. See, first of all, I stretch the change, that's this area. But at some point, the material does not elongate it because that goes to the limited point of the elongation. That's the here. That's the we called sorry, yield point. And then what happened? What's the next of yield point? So yield point, after yield point, that elastic range sometimes changed, might sometimes increasingly increase the range of elasticity. There is this range, and then in some point that is just broken, right? That's fracture point. So this material, right, that has different this kind of property. All material has the similar, right? So the yield point is important because that point, before that point, material has like elongated, and then go back to the initial point, because once I stretch and I stopped, that become the initial like shapes. So yield point is material's permanent deformation limit. So even though I push force on the material until yield point, that come back to the original shapes, original form. That's yield point. But after yield point, the material cannot come back to original shapes, right? So that's why when you use material, we should not use the force over the yield point. That means that permanently change the object, that could change its internal structure of the material, that can be like defect of the material, right? So this is the stress strain diagram. And all right, I have some of the other slides. So hardness also another important point of material property, the ability to resist denting or scratching. So hardness has pros and cons. So if you have too much hardness, that means brittle. or if we don't have enough hardness, that means so soft. So we have pro and cons. So that's why engineers use unique way of hardness. So like this. What is this? This is chocolate cake. So inside is soft and outside is hard. So this is the way engineers use the hardness. So engineers, when they make a material such as like plastic or metal, they tend to make inside soft and outside hard. So this is an example. So one example is the hardening. So to make to change the property of metal, uh, people we treat heat. Like, this is gas touch, and then put a heat here to the material by high temperature, and then once the once increases temperature, and then the put the material into this can. This is a oil can, or sometimes they use sand or oil. That means mild temperature. So once you put here, that temperature slowly goes down, right? That means the objects become soft. Material becomes soft in this. This is moderate. Moderate cooling. And then once again, next they put increase temperature using gas torch, particularly the outside, and then put into the water. That is rapid cooling. So rapid cooling make the material hard. That's the one way they change the uh, hardness of the material. So moderate cooling make soft, and rapid cooling make hard. So they do both. Right? They heat they heat up the material entirely, and then second time they heat the temperature just outside, and then do rapid cooling. That's called case hardening. So most of metal products use the case hardening. And next is chemical properties. So chemical properties means characteristics of metal that determine how it will react chemically. So this is a very interesting learning topic. So there is also related to corrosion. Most of metal has corrosion properties, become corrode. So the main reason a metal become corrode, metal is corrode, is oxygen. Oxygen is primary region. So this is one example. So let's say this iron or steel. So iron is ferrous, right? But sometimes drop of moisture is two hydrogen and one oxygen, right? So hydrogens tend to combine with phosphorus, right? That to get their characteristics. So once moisture goes into iron, then the hydrogen, I'm sorry, not hydrogen, sorry, that's not hydrogen, oxygen meet ferrous. So then become two ferrous and three oxygen. That's their properties, their characteristics. So two oxygen meet, two ferrous meet three oxygen. then become oxidized ferrous. That is corrosion, like this. So that's why the metal or iron become corrosion, right? So, but sometimes we use a different method to prevent corrosion, such as resist a certain material chemical. So this is a way, one way to make prevent corrosion, such as like shooting the paint glue gun and like paint the metal so that protect from the oxygen, like this one. So this is called powder coating. So using powder that paint the metal and then to prevent the corrosion. So and then another way is aluminum and anodide. I gotta show you this principle. This is also interesting question. Why does aluminum corrode, right? So aluminum usually doesn't corrode. So, but aluminum is very reactive material, but that doesn't corrode. Why? Because aluminum has a certain properties. That is like this. Let's say this is aluminum metal, but if we see the aluminum metal, we cannot see the actually this properties, this layer, but there's another layer on top of aluminum, that is oxygen layer. So aluminum very active metal, very reactive metal. So aluminum, when we put aluminum into the atmosphere, like in the like natural life, so that tend to combine with oxygen, and then that create a thin layer that protect the aluminum. So the aluminum inside, and then the oxygen combined with aluminum, but this creates a layer that protects the aluminum, right? This is the principle why aluminum doesn't corrode. Interesting, right? But sometimes aluminum become corrode when they meet salt water. So it's a chlorine. So salt water is NaCl. So chlorines, sodium chlorine. So when we pour like a salt water into the aluminum, then they become corrode because of chlorine. Chlorine tend to combine with aluminum, then become corrode. So because aluminum tend to have covalent bond with chlorine. That is Al and Cl3. So one aluminum combined with three chlorines. So this is because aluminum has in the aluminum outer shell has three electrons, and then three electrons tend to combine with three chlorines. Let's say here. These are electrons. Aluminum has a three electrons. So these electron combine with chlorine. That's covalent bonding. And then the thermal properties also have. So most of metal products has a certain thermal properties. So these are example by material. So wood doesn't transfer heat because wood does not have low, does not is low thermal conductivity, very low. And then I'm sorry, that was metal, but wood has very low, and glass has low, but metal has high thermal conductivity, and then particularly silver, copper has high thermal conductivity, and aluminum, brass, iron has low thermal conductivity. So aluminum and copper has high thermal conductivity, and silver is highest uh, thermal and electric conductivity. But why don't you use the silver for like wire, electricity wire? Yeah, because silver is expensive. And this one, electronical and magnetic properties. So all metal, most of metal has electrical conductivity because metal use metallic binding like this. So metal has a lot of electrons around their atom. These are the black dots are electrons. So electrons, lots of electrons. So the electrons helped transfer electricity. So I summarized their order. So silver is highest one, and then copper, gold, aluminum, zinc, nickel, iron, platinum, and steel. This is their order. And then we can see these elements in their periodic table. So, so aluminum here. So that means it has lots of electrons in their outer shell. So that has three, aluminum has three, and then I'm sorry, yeah, aluminum has three, and then zinc has a lot, and then copper and nickel and silver, and these areas of metal has high electrical or magnetic conductivity. And I have few slides, but this is also, I just quickly move this slide. So acoustical properties. So each material has acoustical properties, which is a material's ability to transmit sound wave. So in certain situation, we don't want to transmit sound wave, such as this is room. So sometimes we paint or we paste like wallpaper that prevent sound wave transmit, or carpet also prevents sound wave transmit. So, but sometimes in this theater also sometimes use the sound reflection using certain material. So if you like play certain song music and then reflect to the audience. So that's why theater engineers use this principle for the acoustical properties. And optical properties also one consideration. So how material reacts to the light wave. So has two characteristics, opacity and color. That also we use the clear material for this greenhouse. All right, so this lecture we looked at the properties of material. So just remember 7 properties. What was the 7 properties? I said my goal, try to spell computer, but she said she forgot to put U and T E. She doesn't know R, so she said, hey. So chemical and optical and mechanical and physical, and thermal, and electronical, and acoustical. So 7 properties. So you can use these 7 properties when you teach engineering design projects, and then when students choose material, we can use the 7 properties as a assessment criteria. All right, thank you for watching my video, and then let's take the exam on the Blackboard. Thank you.